Thank you so much for having me, especially because I know there's a lot of other really interesting talks happening, so grateful to have your time. My name is Masih. I'm a tech lead in Protocol Labs. I'm mostly involved with problems related to content routing and now content onboarding. You've heard of projects like IPNI, for example, or DeStor REST API, also known as Motion. Please come find me or Deep, and we're more than happy to answer your questions. So what are we going to talk about? We're going to cover some background. We're going to talk about why this thing is needed. Then we're going to say what this thing is, but from an engineering perspective. And then we talk about roadmaps and some open questions. So to be a bit selfish, what I want to get out of this is what we should be doing. Tell you about what we have done so far and what we should be doing, what is most useful for SPs to get out from projects like DeStor REST API. Just to point out, there's been 2 other talks on this specific topic by my colleagues. One happened in Singapore, one I believe happened in Iceland, which explains a higher level view of the stuff that we're working on. So if you're more interested on the high level stuff, please go and watch those talks. I recommend watching them anyway. This one is more directed at engineers. So hands up if you have your data on Filecoin today. That's not bad. That's very good. That is good. So I want to take a step back and look at this whole thing a bit holistically, right? Let's see how much data there is in the world anyway. This is a graph that I found online. It's an estimate of how much data exists in the world and some projections on how it's going to grow. About 120 zettabytes, it turns out. And the data that we have in Filecoin today is about 1.5 exabyte. So if you do the math, we are talking about 0.0012% of the data in the world right now is in Filecoin. There is another factor to point out, which is what is the storage power offered by Filecoin right now? That is about 12 exabyte right now. So if you do the math, we're talking about 10% utilization of the power that we have out there today. Right? So the key takeaway from this slide is just to give you a sense of scale and volume, because it's important to understand what it is we want to build for. And also point out this exponentially growing amount of data in the world, right? So whatever system we're designing, whatever ecosystem we're designing, it has to accommodate this exponential growth of data as well as its current scale, right? Because we are in the business of creating a market disruptor in terms of data storage, and these are the characteristics of the sort of market that we're talking about. Now, obviously, we want to put more data on Filecoin. So what I've done is I've created a simple to follow steps to make deals with Filecoin. This is super easy, right? So if you want to store your data on Filecoin and you haven't, for those of you that didn't put your hand up, you get the Boost client, you set up a wallet, obviously transfer some funds to it, then you prepare your data. So you turn it into a car file. If it's bigger than a sector, you've got to chop it up. Then what happens is you import your data into Boost, note down some non-human friendly hashes, then find a storage provider that actually takes your data, make a deal proposal, decide on factors like deal duration, whether to advertise it on IPNI, whether the data is verified, what sort of collateral we should get. If the deal proposal was successful between you and the SP, then fantastic. What you would then do is you note down the UUID of your deal and wait until it gets published. And then once it's published, then you go back and periodically check the chain to understand the data is there. If the data gets slashed, you got to go back to step 6 and repeat this whole thing. And if it expires, you got to go back to step 6 and again repeat this whole thing. If it's not accepted, you also need to go back to step 6 and repeat this whole thing. Now, I on purpose mentioned a lot of keywords that require knowledge and understanding. Right? I saw a hand up, please, if it's.
Yeah, you're missing one important step at 7, that is pricing.
What did you miss the bit?
That helps a lot.
Right. Excellent. I'm glad I'm missing steps because the thing I want to point out is the amount of knowledge that you need to understand this whole system, to make deals with it. And I'm coming from a perspective of somebody that's been exposed to these things more than a typical person. Now, if you remember the opening session that was delivered by Molly during Icebreakers, what I want to get out of this whole thing is to get my grandparents' data on Filecoin, right? This is what I want to do. I want to get my grandparents' data on Filecoin and get it back. And I do not want them to think about sectors and having to split the piece. Like, this is not a conversation you want to have with your grandparents, right? So I want you to think of it in that frame of mind. On the right-hand side, I've listed the stuff you need to know. I'm not going to go over all of these, obviously. I just want to call out a few things that are really important to focus on and hopefully motivate this need of this whole stuff that we're building, right? We're talking about, to the extent, the sort of thing that you need to know about goes as far as having to write a client that speaks libp2p protocol, right? This is from usability perspective, from the things that we are competing with in the Web 2, it's just simply not acceptable in my opinion, right? We are not talking about some system that is usable by all. We are very much on the left-hand side of this chasm curve, right? Let's just say we're going to outsource this deal making, right? I don't want to make deals. I'm just going to pass my data to somebody else. You go make deals. You are the expert, whatever. But I do want to get my data back. Let's talk about what it takes to get data back. Excellent. So if you want to get data back, what you do is you remember at least one of the CIDs that you generated from your car file, from your data. So from get-go, you need to understand CIDs. You need to know if the data was announced to IPNI or wasn't announced to IPNI, and based on that, then your path is different. If it was announced to IPNI, then you could use tools like Lassie, one-line command that you got to get. You need to know what Lassie is. You need to download Lassie, install Lassie, fetch, whatever. If you didn't announce it to IPNI, then you need to find a SP address. You need to contact them directly to understand what language they speak to get the data back. And then you need to speak that language, which may be libp2p, may be HTTP, may involve writing another program. And then you need to also understand whether the deal was made in a verified or non-verified way. Then it gets worse. Even if it was verified, was the SP following the protocols that it was supposed to follow? Because there's no enforcement there, for example, right? And finally, once you get the car back, the thing that was made as a deal, you then have the job of having to uncar it, if you like, to shape it back to your original data form. Because remember, car, in the context of my grandparents, is not a thing they know about. They know about a picture of their grandchildren. They don't know about car files. So when we're talking about dealing with data and getting data back, we need to think about that perspective. It's important, right? So this is the steps that it takes just to get data back. Now, clearly less than ideal, right? So if I want to sum it up, I would say dealing with Filecoin is complicated. It requires a lot of expertise, deep knowledge, and understanding to really utilize the sort of value that Filecoin returns. It obviously needs a lot of small, sharp tools. And by small, sharp tools, I mean the sort of Linux philosophy of having one tool that does something very, very good, and it could be built upon, right? You're talking about a whole ecosystem that requires movement from a community. It requires a number of tools that, and a set of expertise that cannot be contained within one entity. We are building a decentralized web, which by definition should not have a market leader, if you think about it, right? So it is as much about collaboration as it is having good tools that assemble very well, right? And obviously, we need bridges. So we're talking about the sort of representation that is very far removed from the regular presentation that a normal human being that understands how, Apple Photos app works or how to use Google Photos for sharing data, right? This is the sort of interactions that we're talking about. Why should we bother with this at all, right? Why should I just have to deal with the whole Filecoin thing, right? So this is my opinionated view of it. I think there is a lot of obligations or promises or terms and conditions or features that are offered by Web 2 world that are contractual, right? You sign a contract, You give away your privacy or whatever, but what you get is things like availability and so on, right? With the sort of decentralized web or decentralized storage that we're talking about is the sort of guarantees that go beyond this just collateral contractual agreement. We are talking about a network that could sustain its existence in perpetuity if there are people that are interested. And there's something extremely powerful about that. I see that as like a building block for breaking the stagnation of centralized data storage, right? And these are the sort of features that, in my opinion, would take years for big companies to build, right? And we have a network that already has 1.5 exabytes of data. Do not let me fool you with that small percentage. That is no small feat. It is one of the largest decentralized networks out there. So there is a huge opportunity here, right? What we're talking about here is about closing that gap. So that gap, in my opinion, is a leap from Web 2 world to the Web 3 world. What does that leap mean? It initially, at least in my opinion, means extremely opinionated choices. We are talking about a system that has many, many moving parts, and it is very much about taking those configurations away and thinking about what is a good default for people. That is the first step, in my opinion. The second step is about extensibility. We are talking about a ecosystem that pre-existed Filecoin for many, many years. Web 2 has been around for much longer. There are tool chains, there are ecosystems that's been developed. They're far more mature than the stuff that we're building. Integration with, I don't know, IFT, S3, my Raspberry Pi that's controlling the heating system of my house right now, for example, right? There are stuff that are very simply integratable in Web 2 world, right? If you can write something as simple as a HTTP server, right? And these are the sort of integrations that we really want in order to push this chasm to the right-hand side, right? We want to shift things right. That means we need to have familiar primitives. We cannot demand people to understand all these complicated things just to work with Filecoin, right? But at the same time, it doesn't mean we should hide it all. We should also not corner ourselves into creating differentiators based on the technologies that we've created, such as, for example, IPLD DAG generation. For somebody that's uploading cat pictures, really it's just insignificant. But eventually, there is a world that none of us could potentially imagine in which we could have far more efficient interaction if we shape the data right. And we do not want to architect something that would corner us not to be able to take advantage of all these nice things that we build. But at the same time, we need to provide translation from well understood primitives such that we can get the data flowing, because that has really a high multiplier effect, in my opinion. Right? So one of these familiar primitives is a REST API. I'm going to talk about that REST API. That's what it looks like. The QR codes point to repositories that have code in them, for example, Swagger, specification, things like that. So if you want to try something, just scan those. But these are the three basic methods, paths that we came up with in project DeStor REST API. As you can see, it is extremely simple. So what we're talking about is you post blobs, you get an ID back. You get the blob back by giving that ID, and you get the status back by ID/status. That is it. That's all there is to it. Right? This is the sort of API that we're talking about. I think it is a really nice and simple abstraction over the whole Filecoin ecosystem. I don't think it is an abstraction that will last for a long time, but I am reasonably confident as an engineer that's worked in Web 2, obviously, and the Web 3 is something that enables people from not having to pay a extremely high tax to just even imagine getting that guarantees beyond collateral things, right? Getting the value out of Filecoin. So what does it take to run this, right? This is my favorite slide, simply because it is using 3 tools, or let's say 4 executables here, that everyone probably has on their machine. As an engineer, you probably have Docker, because you don't want to download Linux kernel or whatever executable every time. You probably have Echo. You probably have curl, right? And that is all it takes for you to try this API today. Obviously, this trial that you see in front of you is not going to make deals to Filecoin and whatever, but what it enables you to do is to start building applications against this bad boy, which is the thing that you should be worrying about, not the internals of how this maps to Filecoin, at least not yet. Right? So we get to more of that in the questions in a bit and discussions. But the most valuable thing that you see here is printing hello world in Icelandic into a post request and getting an ID back and getting a status of your data back based on that ID and getting the blob back whenever you want. And all entire magic of how this happens is just encapsulated in that. Right? That is the beauty of enabling others, in my opinion, in Project DeStor. Now, what does it work? What's inside of this, right? How does it work internally? There's a presentation coming up. I've seen the slides. I'm not going to spoil it for you, but it's an excellent presentation by Sheena that's going to talk about internals of Singularity V2, which does a lot of the heavy lifting here, right? But what happens in terms of DeStor, which is the subject of this talk, is that DeStor makes a specific use of this wide array of tools that are offered by Singularity V2 to make very opinionated choices in order to deliver on that simple API. So fundamentally, it works with 4 components of Singularity, if we don't count the API. These are executed as separate processes, so as an SP that is, or ISV that's running DeStor, they're independently scalable. They allow you to control how much resources you're spending. There's obvious choices about data publication on systems like IPNI. For those of you who don't know IPNI, think of it as a lookup mechanism. Given a CID, gives you address and metadata back. And interacts with storage providers for us. And this includes online deals, offline deals, whatever the SP likes, right? So then the idea is that that would then connect you to this bigger vision of decentralized content address ecosystem, which once we get the data flowing on it, and I cannot express that enough, we get a lot of potential for value add and killer features that will take years for others to build. Right? That's the general vision here. Diving a little bit deeper into DeStor implementation itself, right now it is a thin wrapper across Singularity, but it is implemented such that it allows you, should you choose to do so, make your own opinionated choices without having to rewrite everything. So for example, there is a simple interface that allows you to create a singular DeStor store, right? There are only 3 Go functions here, so this is a Go application. On the right-hand side, you see the sort of response that you get from the status. So IDs are treated as strings. It so happens to be UUIDs right now. That might change in the future. And you can, as long as you implement that interface on the left-hand side, you can just wrap that around the existing server package that immediately gives you a REST API. Now, if I want to think about how can I use this as a ISV, as somebody who's selling storage, I would think of use cases like, for example, daisy chain. If you have worked with systems like Min.io, for example, one of the features is like tiering feature, a way of moving data from one storage to another storage because the other storage is cheaper, for example, right? Or the data is used less frequently, so I'm going to use it, move it to slower disks, and then use the fast disk for, like data that is hot or whatever, right? These are very specific application decisions. They are very specific business decisions, right? So the point of structuring the code in this way is to allow you to then implement your own store that is calling this current implementation of Singularity V2 store, or calling some other remote thing, or in the middle, inject your own application logic that, for example, does something fancy with encryption, or does something fancy with, for example, offloading data to a specific location, whatever you like, right? But at the end of the day, you end up with a server that is compatible with the specification of DeStor REST API, and it is integratable with other things, right? So you can imagine how you can use this as Lego pieces to build bigger systems. What is configurable in DeStor? I keep going on about taking stuff away. So far, we have exposed a whole bunch of parameters from Singularity V2. If you're familiar with Singularity V2, you'll see those parameters that are standing out for you. The main thing to point out here is that we are learning what is the right abstraction to expose. And so far, this is the first iteration of the MVP implementation. This list is coming from talking to ISVs, talking to SPs, and understanding what it is that they want to expose or have control over. So it is as much of a learning exercise for us as engineers of this project as it is for ISVs and SPs that are integrating with ISPs that have, hopefully, a lot of data that want to onboard. So as you can see, most of the configuration is surrounded around the pricing of the deal, of course, because that affects the bottom line. And then the trade-offs between how often to make deals, where the data lives in the meantime, and so on. So the whole life cycle of the data preparation and data offloading is controllable. And of course, some configurations around IP&I for things like privacy reasons, and you might have a private data that doesn't want to be advertised to the world, and so on. So this is the slide that really want to start a discussion with. The stuff that you see here are a mix of roadmap and open questions that we are thinking about in DeStor implementation. So as a next step, we are thinking about things like access control, what access control looks like to a Web 2 world today, and what it might look like in the future. What changes it entails to the broader ecosystem. By the way, please interrupt me if you have questions. To the broader ecosystem, some of the changes that we're talking about here would involve things like, for example, FIPS, changes in protocol. We're talking about SP selection. So we're talking about, right now, the DeStor API only allows you to specify explicit set of SPs, which have some agreement between ISVs and so on. But eventually, we want to create a marketplace for the good of SPs as well as good of ISVs. If you can store your data cheaper in a decentralized web, then why shouldn't you? Why should you be bound to a specific SP? So this is the sort of control that we want to push back, shift left to the ISV side, if you think about it. We're also thinking about content addressable blobs. So far, I showed you using a UUID, and that is... Sure.
Sorry, yeah, I thought you said we were open to questions. So access control, yesterday in a meeting, I don't know if you were in that meeting, I think you were, there was a request from Banyan to enable or implement UCANs on a Boost Lotus level. In this scenario, what's the thought process and where do you think it fits best, either in like the Motion stack or deeper in the Filecoin stack?
In that specific use case, in my opinion, and it is very opinionated, I think it belongs deeper in the stack, like Lotus and Boost, for example.
Awesome. So that means that remains the same request then. That's awesome. So then we need to find a way to standardize it across the ecosystem.
Absolutely.
Cool. Thank you.
Absolutely.
Yeah, I've got a couple of questions. One's really quick one. If we just go back one slide, repricing. Does this pricing only accommodate pricing in the form of Filecoin? Or pricing in fiat or other current? So
right now it's all in fill. But obviously we are, payment, I think payment is on mine. It's not, it should be. Also sorting out payment or offering control over how the payment happens is another parameter that we should talk about. Because it is possible that fill is not the only thing that is used for exchange. Obviously the whole ecosystem is built around fill. So if you want a faster, more programmatic and scalable way of paying for things, fill would probably fit that bill, but that doesn't mean it's fit for everybody. So that's also an open question, at least for me.
Yeah, so that sort of is a leader then to a broader question in terms of this is definitely closing the chasm, but from a storage provider's perspective, yeah, there still is a significant gap from here to the customer actually being able to use this. And so what is closing that next gap being addressed somewhere else, or how are we intending as a network to close that next gap?
Excellent question. Again, I can offer you my opinions. I want to express these are my opinions. These are not state of the world. Short answer to your question is right now we are cheating. And I think every system should in its first iteration. And by cheating, I mean there is specific contract between ISVs and SPs that obligates them for this much ingress, this much egress, for whatever fee this is signed for, right? You can think of this as a basic agreement between the two. Eventually, we want to make it scalable because you cannot make signed contract for hundreds of SPs out there if you want to create a competitive marketplace. So all of this needs programmatic interaction, selection process, ties into things like retrieval incentives, retrieval checking process for which there's been talks yesterday. I think right now there's a track going on. So the broader changes, or in my opinion, the right vectors to keep pushing towards the right solution there is very much in the making. Right? We are enabling data to flow to make solving questions like this relevant. Right? But you're absolutely right that there is a gap and it needs to be addressed. Right?
So, sorry to hog the mic, but I'm not even vaguely technical. Okay, so excuse my naivety here, but yeah, a customer of ours recently onboarded Victor Chang. For them to actually use this independently of us doing this manually for them, how much is involved for them to move their data from either their on-prem Isilon or from Azure right now?
Right. So I guess help me understand, what perspective are you looking at the problem? Your perspective is from an SP perspective, right?
Yeah.
Excellent. So the problem that we're talking about here involves two parties, or technically three parties. We have the end user, the grandparents. We have ISVs, right, which are building glue code over existing platforms, right, that are targeted solutions or the specific services for specific problems. And we've got SPs that are providing storage at a decentralized network that has a very specific protocol, right? The sort of ecosystem that we're talking about here involves all three of those. So we can't, I feel like I can't answer that question in isolation without involving an ISV, right? Because the solution that we're talking about here would involve an ISV, which would then have expertise to understand how to control these parameters.
So in this case, I would argue that the SP is the ISV. Because they're playing the role. Yeah.
Excellent. So
I don't know.
Oh, he doesn't know what an ISV is.
Independent software vendor.
You're both.
Well, we're not software developers. We have no in-house resource to do that. From my perspective, that's something that, personal opinion, should be developed by Protocol Labs at the central level to be able to, because at the moment, we're talking about closing chasms.
Mm-hmm.
I don't have resources to build this. My customers sure as hell is not going to bother doing that because they don't even know what they're interacting with. So apart from a handful of independent, partially funded projects, who's closing that gap?
That's a good question. So I guess that's where like funding models and so on come in. But without going into like the financial part of it, I want to touch on something that's important, which you pointed out. Eventually, what we want is the sort of solution that you're talking about, which is there is no difference really between SP and ISV. The system is so usable that my grandparents could store photos on SP that you provide without a problem, right? That's the ideal world that we're talking about, right? There are stages in achieving that goal. The first stage is if we have somebody that is in the business of building applications, like higher level applications, like for example, photo management, or for example, mountable storage, for example, like a fuse driver that gives you a drive that you can just copy stuff in, right? If we have that entity that builds that part of the solution, can we make them use Filecoin? And the answer before this sort of thing was no. We can't even make those guys. So forget about grandparents, right? So if that makes sense, there's like layers of complexity here. And we are after having built a decentralized network with a reasonable amount of data, with a reasonable amount of storage power, we are starting to unpick those type of questions. How can we confine the scope of problem to a small, achievable thing, which would make iterative solutions towards this bigger thing? Now, one specific open question that I want to talk about, I'm not sure if it's listed. Yeah, so it's about how do we enable retrieval of data directly from SPs, for example, right? It's like delegation. And these are the open questions that we're going to talk about. The reason I point this out is because these are architectural things that are hard to change, and it is extremely important to get a SP input exactly like you're doing. So I really appreciate this input. The chasm is moving towards the right direction. It has layers, which we are tackling one by one.
Yeah, I think actually part of my question was answered, but maybe I want to focus it a little bit more. So who do you envision actually running the API service? Would an ISV run it in-house as a part of their stack? Would it be like a SaaS thing, like hosted MongoDB or something like that? Could an end user run it? Like where do you actually see the application sitting or the service sitting?
Right. So I guess I keep saying this word ISV. But what does ISV mean? I'm going to give you an example. There's a lot of companies out there that provide, for example, S3 API, S3 compatible storage APIs that are stored on bare metal devices. That's the type of people that we're talking about running this thing. Because what we want to enable them to do is to provide a competitive price point, competitive feature set eventually, right? So does that answer your question, Arkady?
Yeah, I guess I should clarify why I'm asking that. And I guess actually the distinction I meant was, would you, if you were an app developer, could you run this in-house versus being totally a specialist? And that I guess the reason I'm asking has to do with resource consumption and complexity. Like, would it be feasible for someone to be running this on-prem instead of having it be a specialist role?
Absolutely. I think it certainly should be. Yeah, everything I talk about here is open source. You can stand up your own instance, like I said, with the Docker thing. That's not a problem. There are obviously different models here, depending on how much complexity you're willing to accept as an app developer. I could do things very leanly if I have access to some, AWS credit I could burn. I could run this myself and, call it a day. Or I can't be bothered because I am making six-figure income on my app that is, I don't know, blowing up minds or whatever the popular app is. And for me, it's insignificant to pay a monthly fee for an API key. So you can think of it as an app developer that could use a hosted service that runs this thing, an app developer that is doing the whole thing and is talking to SPs directly for a more profound control over communication between SPs. The main thing here is enabling this, providing these small, sharp tools that allows this spectrum of choices, not to make those choices explicitly, right? Does that make sense, Arkady?
Yeah, so Arkady sort of already asked my question, but I just want to get a little even more specific about who's actually hosting this. So taking the grandparent use case, if somebody's building, the end user experience that a non-technical person like grandparents or, in my case, archivists at large institutions would use, is there, you on the previous slide, you mentioned wallet keys are something that's configurable. So, where's the wallet being stored, and is that wallet being mapped to, are there multiple wallets that each map to individual users, or are you expecting there to be one wallet at the instance level and the sort of ISV or whoever's operating this particular Motion or DeStor REST API instance would just have one wallet, kind of like Web3 storage, that they're using to onboard everyone's data?
Yep, excellent question. So that's one of the feature sets that we are trying to prioritize, actually, multi-wallet. Right now, though, it is all about the thinnest possible deliverable, which is one wallet per instance. So that problem is basically pushed upwards towards ISV, because if I reiterate, ISVs, we think of ISVs as these entities that have software developers. They build integrations for a living, right? So it is what is the right wallet distribution over user? You have one spectrum where you have one wallet per user, They need to know about it. We don't even store the keys. You just sign it, or some remote signing or whatever. There is another point in the spectrum, which is there's one wallet for all people in the world that talk to me as an ISV, and I'm going to put everything in that one wallet. Simple. I just replicate the key or whatever, right? There's the spectrums here, and the right answer to them is obviously application specific. So at this stage of the project, the key for us is to provide the right primitives that enables ISV software developers to build the integration they want, right? And then what we do is we talk to the ISVs to understand what features are more important from like platform perspective for us to then prioritize and enable them to achieve what they want to do, right? So to answer your question, right now is one wallet per instance, and it is up to the ISV to implement distribution or stand up multiple DeStor instances to separate wallets. And eventually, we absolutely aim to support multi-wallet. But what the configuration for that looks like is unclear right now, because remember, one of the key goals of this project is to provide abstraction, and abstractions are very difficult things to build or get right from get-go. I think right now it could talk to one Singularity instance because, yeah, so.
We have one final question, if you don't mind. We're a little behind now.
Yeah, I'll try and be quick. So this feels like this should be a client library that any ISV could then just go build into their applications, and then that would talk to a Singularity, and that would be sort of the most efficient way. Is there a specific ISV that you have in mind that you could just test this with, or something that like versus the abstraction? A lot of things that we've seen on the storage side is just what they want is an S3 compatible endpoint, and building something like that where you have your abstraction layer that exposes an S3 endpoint as part of it, maybe like a fast path to market. But yeah, simple is better for sure from a ISV perspective.
So I have a URL that's not on the slide for you and a QR code to scan. The URL is a repo in Filecoin project GitHub.org called Motion-S3-connector. And what that does is that it builds on top of a open source project that gives you an S3 compatible API that just works with Motion. So as somebody that has built integrations already on top of S3 API, you can just run that as a separate container. In fact, it offers a Docker Compose that provides all of this for you. You just run that Docker Compose, you get an S3 API back, and you just start hitting it. That exists already today. In terms of the QR code that I'm talking about, on the right-hand side, we have a program for getting interested parties involved for that specific point that you kindly mentioned, which is to work closely with them to understand what is worth solving, right? So we already have that program. The beta release of DeStor has just finished, or is just finishing in the end of September. It's on time to get delivered. If you're interested in getting involved, we would love to hear about you, because what we want to make sure is, are we building the right thing, and prioritization. There's so much interesting work to do in this domain. There's so much potential. The hardest thing is to choose, and that's where the feedback thing comes from.
There's no more time.
How coupled is this right now?
Sorry?
The internal workings of it. I need a Singularity, some kind of HTTP server you are running. What's the connection in between? I just focus on one now.
Yep.
Do I get files out of my HTTP server, or is it that directly streaming into a Singularity? Where is the point to, let me say, change things? If I want to take Singularity out, what do I get from the HTTP? Do I get files? Do I get a byte stream?
You get octet stream.
Yeah, but from your side, what sits in front of the Singularity?
Right. So I guess I can talk about this. So from Singularity side, what we get back is car files. Obviously, we are encapsulating how the raw cat picture maps to the car file, and that is an abstraction that we hope an end user an ISV doesn't have to worry about. So that's completely encapsulated inside DeStor, but I can go into details on how it actually gets decomposed. Actually, this is a very good segue into Shinan's talk. I think Shinan is going to cover it in his talk. But essentially, all the communication between these components is just pure REST HTTP. DeStor talks a Singularity REST API, and DeStor provides a REST API. You can use curl to try all of these or debug things. In terms of deeper debugging, it was on the roadmap to expose more Filecoin primitives for the expert view. You know, in an ISV world, you can imagine a system admin that understands what deal slashing is and might want to detect what happened to this thing that I uploaded. And for those users, we are aiming to expose a diagnostics API that exposes more of these more detail about Filecoin that allows them to then dig in. But overall, from usability perspective, you really shouldn't need to know about deal slashing to understand that, hey, my replication factor has dropped by 1. Because replication factor is a really nice phrase, and it's something that's understood by everybody, right? We just need to map that rightly and correctly to Filecoin primitives, right? But obviously, as an admin, you want to know more. So we are certainly planning to add that. Does that answer your question?
Not really, but we can.
Go offline.
You've got to keep me honest. Please find me.
All right. Thank you so much, Masih. Please round of applause.